Hey students, in this video we're going to cover graphing trigonometric functions. Our two objectives are to learn to graph the sine function and to learn to graph the cosine function. So first, both sine and cosine are defined on the unit circle. The domain for both sine and cosine is the set of angles that give us a sine or a cosine value. So you can see on a unit circle, since the circle is continuous, every angle is possible. So the domain is all real numbers. And we know that the unit circle it has a radius of 1. So the largest a value can be is +1. And the smallest the value can be is -1. So remember, going horizontally, this is going to cover our possible cosine values. So we see that cosine is going to be something between +1 and -1. That's our range. And then if we look vertically, we get the same thing for sine. The highest it can be is 1. The lowest it can be is -1. And every 360 degrees, we start back over. And completing a circle is going to be called the period of the sine function or the cosine function. So we have two videos that are on Desmos that show the relationship between a unit circle and sine. We're going to play this first one. It's kind of meta. It's a video within a video. So here you go. So now if you look at the graph, you see that we're drawing a wave, and after we hit 2 pi, the graph repeats itself. And again, this point where it repeats itself is called the period. So like right here is where the graph starts over. And if you were paying attention to the angle values on the graph, you see that, let's go back a moment. You will see that the angles keep going up by degrees, and we have the angle in degrees and in radians. And even though we start over, the angle keeps going. So at 360, we just keep going up to 361, up to 720. And if we completed it, it would go backwards and go back to 0. And so the cosine graph, the sine graph, it starts at 0, goes up to 1, goes down to -1, goes back to 0, and it repeats. The cosine graph, however, it starts at +1. The y value is +1, and it does the same thing. It has a period of 2 pi, and every 2 pi radians or 360 degrees, the graph repeats. So this portion of the graph, if we divide these into two parts, so we can see that the part from 0 to 2 pi is the same as the part from 2 pi to 4 pi. And so every time the graph goes 2 pi radians, the graph is going to complete a period. So now that's the basic sine and cosine graph. Now we know from first semester that we can do transformations to these graphs. We can shift it left or right, up or down, and we can have horizontal or vertical compressions. And so that's what we're going to spend the rest of this video doing. All right, so the key points on the sine graph. Now we can go back to our unit circle quickly so we can actually see these. Discard, all right, sure. All right, so if we go back to our unit circle, we can see the key points that we're going to use are, we're going to use 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So in radians, that's going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we have 5 key points: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Let's get that video. And the sine values are respectively 0, 1, 0, -1, and 0. We just need those 5 points to draw any sine graph, or their equivalents after we apply a transformation. So the first transformation that we can have is a horizontal transformation. And we already know that if the value is negative, it means the graph shifts to the right. If the graph is positive, if the value is positive, it means the graph actually shifts to the left. And here again is a video that shows that. So when B is positive, we see the graph is going to when b is negative, the value is going to move to the graph is going to move to the right, and when b is negative, the graph is going to move to the left. The red graph is just the graph of sine theta, and what we're graphing is the blue graph is just an animated version of this graph. But we see the graph doesn't change size, it just relocates horizontally. And what we're going to call this is a phase shift. This is called a phase shift because the graph repeats. So generally when we apply a transformation to a graph, the entire graph moves. But compared to the regular sine function, the graph is out of phase, which means that the parts don't overlap. It means that it's shifted to the left or the right. And so to graph this theta minus b, we just need to set theta minus b equal to those 5 key values and solve for theta. So when we want to graph one period of theta minus pi over 2, so remember our original key points are 0, pi divided by 2, pi, 3 pi over 2, and 2 pi. So our new key points are going to be theta minus pi over 2 equals 0, which obviously theta equals pi over 2. Then we get theta minus pi over 2 is going to equal pi over 2. And so if we add pi over 2 to both sides, we get theta equals 2 pi over 2, which is just pi. And then we get theta minus pi over 2 equals pi. And if we add pi over 2, we're going to get theta equals 2 pi over 2 plus pi over 2, which is going to be 3 pi over 2. We have theta minus pi over 2 equals 3 pi over 2. And so then if we add pi over 2 to both sides, we're going to get theta equals 4 pi over 2 or just 2 pi. And the last one is theta minus pi divided by 2 equals 2 pi, which is 4 pi over 2. Or if we add pi over 2 to both sides, theta is going to be 5 pi divided by 2. So if we go back a couple of pages, now remember, these are the 5 sine values. We didn't do anything to those values. We shifted the theta values by pi over 2. So when we make our table, we'll make our table here. So now our new key values are pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. So if we make our little table, which is the most important part, all of the graphs kind of look the same. So we don't necessarily really need to graph these. It's more important that you can find the points. So now our new points are pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. And those sine values are still going to be the same. We start at 0, go up to 1, go back to 0, go down to -1, and go back to 0. So now we need to plot the point pi over 2, 0. That point is here. The point pi 1 is going to be right here. 3 pi over 2, 0 is right here. 2 pi -1 is right here. And 5 pi over 2, 0 is here. And then we just draw a smooth, continuous curve between the points. We don't make it have we don't do like this, make a line segment or something like that. That is incorrect. But that is us graphing one period of theta minus pi over 2. Next is we have a transformation where we can multiply the sine value by something. That value in the front, A, is the amplitude, and the amplitude is just going to stretch that graph vertically. Now, if we look at this animation, we see that when A is greater than 1, the graph is going to stretch. And just like we know from our first semester, when A is less than 1, the graph is going to flatten. And if A is negative, the graph is going to flip over the x-axis, but it's still going to stretch according to how big A is. And so the range, I don't know why this bracket went right here. So the range, instead of being 1 to -1 to 1 is going to be -a to a, because we're multiplying the sine values by a. So in this case, the output values are going to change, but the input values don't. So our key values of 0, pi over 2, 3 pi over 2, 0 pi over 2 pi, 3 pi over 2, and 2 pi are going to stay the same. So now we are graphing one period of 2 sine theta. So first we can just graph sine theta. So we get 0. At pi over 2, we go up to 1. At pi, we go back down to 0. At 3 pi over 2, we go down to -1. And at 2 pi, we go back to 0. So the basic graph of sine is something like this. I can't draw, but, you know. All right, so let's use a different color. Let's go to blue. All right. Nope. So let's make a table. So we're going to make our table where we're going to put in our theta values, 3, 4, 5. All right. So we get 0, pi divided by 2, pi, 3 pi over 2, and 2 pi. Now, what goes in here is going to be 2 sine theta. So we're going to actually do this slightly backwards. We'll add one more column so we can put those old sine values in. So the old sine values were 0, 1, 0, -1, and 0. So now all we're doing is multiplying these values by 2. So 2 times 0 is still going to be 0. 2 times 1 is going to be 2. 2 times 0 is going to be 0. 2 times -1 is -2. 0 times 2 is 0. Why did I put 2? Whew. All right, 0. So now when we graph the blue graph, we're going to have 0, 0. At pi over 2, we go all the way up to 2 instead. At pi, we go back to 0. At 3 pi over 2, we go down to -2. And at 2 pi, we go back to 0. So when we draw this, we now get a vertically stretched sine wave by a factor of 2. And so that's how we graph the transformation of just a times sine theta. The next thing that we could have is the actual angle itself is going to be multiplied by a value. And that value affects how often the graph repeats. So the base graph is going to repeat every 2 pi radians. The period for sine of some value multiplied by the angle is you take 2 pi and you divide it by c. So now the red graph in this video is the basic sine graph. And our video is going to start with, let's see. Let's pause this. Oh, keep going just a little bit more. So you can see that when we're C is a large value, is going to make the graph narrower. And all right, we'll go back just one. All right, so right here, if you can see this, it's C equals 2. And so the period is going to be 2 pi divided by 2, which means that we get pi. So every pi radians, the graph is going to repeat. So when C is a large value, the graph is going to shrink in. And when C is between 0 and 1, the graph is going to stretch out. So if we go forward a little bit, so go back. So like here, we see that C equals a half. And so then 2 pi divided by a half is 4 pi. And so we can see that that graph stretches out and it's going to repeat every 4 pi radians. So the period is what is affected by the C value. I get it. So the way we find the key points for sine C theta is the first thing that you have to do is find the new period that's 2 pi divided by C. And for this graph for sine theta, the new period is going to be 2 pi divided by 4, which is pi over 2. So that means that every pi over 2 radians, or every 90 degrees, the graph is going to complete a cycle. The next thing that you have to do is divide that new period by 4, and that gets you your quarter periods. So like for our basic graph, we were doing 2 pi divided by 4, and that's pi over 2. And you can see that to get to the next value in the theta column, all we're doing is adding pi over 2. That's your quarter period. So for the new graph for theta, the quarter period is pi divided by 8, because pi divided by 2 divided by 4 is pi over 8. So that means that since we're starting at 0, what we need to do is start with our first value and just add our quarter period until we have 5 values. So now we're going to, from 0, we're going to add pi over 8. We're going to add pi over 8 again. That's going to give us 2 pi divided by 8. And I recommend, before you simplify, you just keep adding your quarter period until you get your 5 points. So we're going to have 0 pi over 8, 1 pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi divided by 8. Now, the even numbers are going to reduce or simplify. So pi over 8 is going to, 2 pi over 8 is going to be the same as pi over 4. 3 pi over 8 will stay the same. And 4 pi over 8 is pi over 2, which again, in radians is 90 degrees. So we see that after 90 degrees, we've completed a whole rotation around the unit circle. So now we're actually going to graph one period of 2/3 sine 2/3 theta. And so the first thing that we need to do is find our new period. So we're going to say our new period is 2 pi divided by 2/3. Now, again, we just multiply by the reciprocal. So 3/2 times 2 pi is going to equal 3 pi. So now that means that every 3 pi radians, the graph is going to repeat. So our new period is 3 pi. Our quarter period is just going to be that 3 pi value is 3 pi divided by 4. So now, because we don't have a horizontal shift applied to the graph, our first value in our table is going to be 0. So we're going to have 0. We get some other value. So it's 3, 4, 5. We'll make a table out of this. So from 0, we're going to add 3 pi over 4. We're going to add 3 pi over 4 again. That's going to give us 6 pi over 4. We're going to add 3 pi over 4 again. That's going to give us 9 pi over 4. We're going to add 3 pi over 4 again. That's going to give us 12 pi over 4. Is that 5 values? 1, 2, 3, 4, 5. All right, we did it. We actually don't need that last one. So again, the sine values are going to repeat. They're going to be the same ones that we started with. So 0 up to 1, back to 0, down to -1, and back to 0. So now all we need to do is graph that. So we'll graph this along with the regular sine graph. So the transformed graph is going to be a 0, 0, 3 pi over 4, 1, 6 pi over 4. Now 6 pi over 4 reduces to be 3 pi over 2. So 3 pi over 2, we go back to 0. At 9 pi over 4, we go down to -1. And at 12 pi divided by 4 is the same as 3 pi. We get back to 3 pi. So I'm sorry, we get back to 0. So we get a flatter graph. So that's the sine 2/3 theta. Now, if we use the original graph, so the original graph is going to be 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. So again, we can see that the 2/3 flattens that graph out, which makes it horizontally stretch out a little bit. So that is how we graph the transformation of some value being multiplied by the angle. Now, the last thing that we can do is put all of this stuff together. So we could have in amplitude, some value multiplied by the angle, it shifts horizontally and it could also shift vertically. Now to do that, the first thing that we have to do is identify the phase shift. This is our phase shift, the theta minus b. The second thing that you need to do is get that new period. The third thing that you have to do is get your key values. The fourth thing that we do is multiply those y values in the sine table by our amplitude, and then we apply our vertical shift. So we have this graph of 3 sine 2/3 theta plus pi over 4 minus 1. It looks intimidating, but it's not. All right, so the first thing is our phase shift is going to be this thing, theta plus pi over 4. So we get, we're going to shift left pi over 4 units. So that means that our first value in our table is negative pi over 4, because we would start at 0, but we're going to start at negative pi over 4. So when we make our table, so we get this table, let's see, so 1, 2, 3, 4, and 5. So our first value is negative pi divided by 4. Cool. So next we need to find our period, and that's going to be, so our new period, I'm pretty sure we did this on the other slide, is 2 pi divided by 2/3. Yeah, we did do this. So that's going to give us 3 pi. So now our quarter period is going to equal just 3 pi divided by 4. So that means that from this negative pi over 4, we just need to keep adding 3 pi over 4. So now negative pi over 4 plus 3 pi over 4 is 2 pi over 4. And I encourage you to not simplify this stuff yet, because it helps you. The simplified version isn't going to help you get to the next one easily. So now we need to do 2 pi over 4 plus another 3 pi over 4. That's going to be 5 pi over 4. So we get 5 pi divided by 4, and then 5 pi over 4 plus 3 pi over 4 is going to be 8 pi divided by 4. So 8 pi over 4. And I trust that you believe me when I tell you that the next one is going to be, can I turn it into a pi? We'll say 11 pi divided by 4. So 11 pi over 4. Now, our original sine values in our table are 0, 1, 0, -1, and 0. So what we need to do now is multiply all of those values by 3. So that's going to give us 0, 3, 0, -3, and 0. So let's cross out the things that we've done. We've done the 2/3. We've done the pi over 4. We've multiplied everything by 3. And the last thing that we need to do is subtract 1 from all of these. So we're going to get -1, 2, -1, -4, and -1. So that means those are the values that go in our table. So we get -1, 2, -1, -4, and -1. Now we're going to graph the original sine function, which would be, we'll graph. All right, so let's graph the original sine function in blue, for instance. So we know we start at 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. So we draw our wave like this. So that's one period of that. And then our transformation is going to be, all right, so now we need to start at negative pi over 4, -1. So we're going to start at negative pi over 4, -1 at 2 pi over 4. All right, so we actually didn't reduce these. That's going to be the same as pi over 2. So then at pi over 2, we need to be up at 2. At 5 pi over 4, we need to be back at -1. At 8 pi over 4, that's the same as 2 pi. We need to be down at -4. So at 2 pi, we need to be way down at -4. And at 11 pi over 4, we need to be back at -1. So we get a sine wave that looks something like this. Now we can see that the distance that we cover from our baseline, that is a distance of 3, and the distance from our baseline down to the lowest value is also a distance of 3. So the total range is just going to be 2 times your amplitude in absolute value, so in this case 6. But that is how we graph a completely transformed sine wave. We first find the phase shift, find our period, find the quarter period, apply the amplitude, and apply a vertical shift. So graphing the cosine function. Oh, I guess I'll need a slide. All right, so graphing the cosine function. It is identical to graphing the sine function. The only difference is that our values, sine started out at 0, went to 1, went back to 0, went to -1, and went to 0. All this cosine function is all of those values shifted back 90 degrees. So instead of starting at 0, we start at 1, go to 0, go down to -1, go back to 0, go back up to 1. That's it. So it's all of the other steps are exactly the same. So the last thing we're going to do in this video is graph one period of 4 cosine 2 times theta minus pi over 6 plus 2. So the first thing that we need to do is apply our phase shift. So in this case, we're going to shift right pi over 6 units. Cool. So that's our starting point in our table, whatever our phase shift is. So the first value that we're going to have is pi over 6. Now we're going to get some squirrely fractions when we're doing this, I think. So next we need to find our new period. So the period is equal to 2 pi divided by 2, which equals pi. So our quarter period, I can spell. So our quarter period is equal to just our period, and we divide by 4. So pi divided by 4. So that means we need to add pi over 4 every time. So from pi over 6, we're going to add pi over 4. So now pi over 6 plus pi over 4. So now this is going to require some fraction stuff, right? So we get 2 pi over 12 plus 3 pi over 12. That's going to equal 5 pi over 12. So 5 pi over 12. So we get 5 pi over 12 here. So you know what? My recommendation is now, so if we're adding pi over 4, that's going to be the same as 3 pi over 12. That's going to help us. So let's temporarily write all of our angles in terms of pi over 12. So we get pi over 6. And that's going to be the same as, that was 2 pi divided by 12. So now the next one is going to be 8 pi over 12. The next one is 11 pi over 12. And the last one will be 14 pi over 12. Oh, I'm smart. Use the eraser. Write this better. Oh, did too much. All right, so we get 8 pi over 12, and the last one, the next to last was 11 pi over 12. Now, if we reduce some of these, 8 pi over 12 is the same as, 2 pi over 3. So 2 pi divided by 3. And 14 pi over 12 is the same as 7 pi over 6, which is 150 degrees. So now, if you think about this, we're adding 45 degrees every time. So if this is 150 degrees, then this angle in degrees is 105 degrees. This angle is, we're adding pi over 12. I'm sorry, we're adding 15. We're adding 45 degrees each time. Yeah. Okay. So this angle is, so we're starting out at 30 degrees. So we go from 30 to 75 degrees to 120 degrees to 165 degrees. And if we add 45 one more time, that is 210 degrees. So let's see if we plot our point. Cosine goes from positive 1 down to 0, down to negative 1, back to 0, back to 1. So now first thing we need to do is multiply those values by 4. So we get 4, 0, negative 4, 0, and 4. So we multiply by 4, and then we're going to add 2. And so we would get 6, 2, negative 2, 2, and 6. So 6, 2, negative 2, 2, and 6. And so now we're just going to have to like eyeball these values. So the ones that fall on, so pi over 6, we'll say is right here. 5 pi over 12. So pi over 6 is going to be right there. 2 pi over 3 is going to be, we'll say like right here. And 7 pi over 6 is going to be between 5 pi over 4 and pi. So we'll say it's like right here. And then the 2 pi over 12 values, they're going to be halfway points between each of these circles. So we'll say that, so first we need to start at pi over 6, 6. So we're going to start our graph actually up here. And then at 5 pi over 12, so halfway between there, we'll say is like around here. And then at, 2 pi over 3, we need to be at negative 2. So 2 pi over 3 is negative 2. So now we're using these values on the x-axis as just like little barometers for where we need to be. 11 pi over 12, that's going to be a halfway point like here. So at 11 pi over 12, we need to be back at 2. So we'll put that point like right around there. And then at 7 pi over 6, we already have like a ghost point that we're going to put up here. So now what we can do is take these values off the x-axis because they don't actually belong on that graph. Nope, take it back, Mr. Martin. Take it back. All right, it will not let me erase these points for whatever reason. Oh, zoom out. Nope. Keep them. God, I messed it up. All right, so hold on a moment. So ignore these values on the axis. We'll like color them in, but the way our graph should look is we start at 6, go down to negative 2, and we get something like that. Now, the reason our graph is kind of wonky is that it's hard to find graph paper that's in terms of the pi over whatever's that you need. And so you have to like improvise a lot of times. So in this case, we had one that's in terms of pi over 4. So that's why it looks kind of weird. But the important part is that you can get these values and fill in the table. The graph's not that important. Hopefully the video was helpful. See y'all.